This is a second video in a series on the basics of matrices being used with a system of equations. And in this one, we're going to take a look at how to read an augmented matrix that was transformed with the Gauss-Jordan elimination method. Now, you may remember that I highly recommend technology. In your textbook, they're going to show you how to solve these matrices with pencil and paper, essentially. And I really recommend you avoid all of that and go straight to an app or calculator or a website that can do this for you. There's just so many ways to make arithmetic mistakes when you try to do it by hand. And in today's world of technology, why not use it? So let's start at the beginning. The Gauss-Jordan elimination method is a step-by-step process that transforms matrices into a very specific format. When a matrix is transformed by the Gauss-Jordan method, the result will be a diagonal form. On the left side of the augmented line, it will have ones down the diagonal and zeros everywhere else, while on the right side there will be values for each variable. So for example, if I had a matrix that was 2 rows, then I would have a 1, a 0, an augmented line, and then some sort of number on this right-hand side. And in the second row, I would have a 0, a 1, and some sort of number on the right-hand side. We'll see those ones going along the diagonal that's to the left of the augmented line and zeros everywhere else. Now on the right-hand side, there will be values, because really what this will tell you is this 1 in the top, you'll remember, is for the variable x. So it'll tell you x will equal whatever number is on that top row. And then the y on the bottom with this 1 is going to tell you that y equals whatever that second number is. Okay, so let's take a look at how to interpret this example that I have provided. On the left-hand side, you see a matrix that is full of numbers. And so this tells us that we had a system of equations and it had 3 equations with 3 variables. This first row would have come from an equation that read 3x minus 6y plus 9z equals 0. And then we would have had 4x minus 6y plus 8z equals negative 4. And we would type all of this into an electronic website, and then we would ask the website or a calculator to change this to a Gauss-Jordan form. And when it changes it to a Gauss-Jordan form, it's going to have ones right along the diagonal there, zeros everywhere else on the left-hand side, and on the right-hand side, negative 3, 0, 1 for this specific system of equations. All right, so to interpret this final answer that it gives us, we need to remember that this first column is for the variable x, and so it's telling us 1x equals negative 3. And for the second column in our second row where the 1 is, it tells us 1y equals 0. And the last row tells us that z equals positive 1. Altogether, that will tell us that the ordered triple, because it's x, y, z, is negative 3, 0, 1, where the 3 lines would intersect if it were graphed. If it's not graphed, then it tells us the ordered triple that satisfies all 3 equations. So if I were to take negative 3, substitute it in for x, take 0, substitute it in for y, and 1 in for z, I would find out the first equation is true with that ordered triple. I'd find the second equation is true with that ordered triple, and the third equation is true with that ordered triple. So the augmented matrix that's created with the Gauss-Jordan method that you either do by hand, which I don't recommend, or with an app tells us the answer for the system of equations.